In this problem, we're given an RLC network with the following parameter values: R equal 10 ohms, L equal 1 Henry, and C equal 2 farad. Determine the values of the circuit elements if the circuit is magnitude scale by a factor of 100 and frequency scale by a factor of 10,000. So from the text, if we're going to magnitude scale, of course for the resistance we have R prime equal to Km times R. So the magnitude scale was 100. So that gives us 1,000 ohms, okay, or 1 kilo ohm. For the inductance, we magnitude scale. We multiply the magnitude scaling factor by the L. So here we have 100 times 1, or 100 henries. And for the capacitor, if we magnitude scale, we get C divided by the scale factor, so we have 2 divided by 100.02 farads. Okay, so after the magnitude scale, we get that. Now, for the frequency scale, the resistance is not affected by the frequency, so here's our final value of resistance. So now for the frequency scale, for the inductance, we'll have our final value, we'll call it L double prime, is going to be L prime divided by K sub F. So we have 100 henries divided by 10 to the 4th, 0.01 henries, or 10 millihenries. And for the capacitance, we have C prime divided by K sub F. So then we have 0.02 divided by 10 to the 4th, and we get 2 microfarads. So here are our final values in red for the inductance and for the capacitance.